So next we have another strategy is the top-down approach, and this is the most commonly used approach. In this, we are going from generic requirements or details to minute level details. So in this we are going to first of all identify the high level entities. For instance, if I'm working with the library management system, I'll think of the entities or the objects um, that may exist in the system. For instance, a book is an entity, author is an entity, right? So first of all, I'll be defining these business needs. Next, I'll define the relationships between these entities. So these entities are going to become the tables or the relations in the relational database. And the next step is to define the relation amongst these tables. And the last step is to define the attributes. So these are the two different approaches. In the bottom up, we are working with the attributes, then we are creating the tables, and then we are defining the relationships. Whereas in the top down approach, we are going to first identify the entities, then we are going to define the relationships, and lastly we'll add in the attributes. So in the top-down approach, we are going to design the entity relationship model, which we'll be looking at in a few minutes. So database design consists of three main phases. First is a conceptual design. So to build the conceptual representation of the database, which includes identification of the important entities, relationships, and attributes. It involves the creation of a conceptual data model of the part of the enterprise that we are interested in modeling. So in the conceptual design, we are just going to identify the entities, what are the objects that we are going to um, work with, and secondly, we will define the relationships. So uh, entities are the tables, you can say. For instance, book is an entity, author is an entity, and what kind of relationship exists between, does any relationship exist between a book and an author? Yes, a book has an author, right? So there is a relation that is existing between the two. So we build a model independent of any implementation details such as target DBMS software, application programs, programming languages, hardware platform, or any other physical considerations. So in this step, we are just going to design a diagram or create a blueprint or architecture of the database, in which will be just working with the entities and the relationships. Then we have the logical design. So logical design is to translate the conceptual representation to the logical structure of the database, which includes designing the relations. So we choose a database model, for, usually a relational database, and then we convert the entities and relationships into the tables. And lastly, we have the physical design, and the physical design decide how to store the data. For example, what data types are going to be there for the book ID, what data type will be for the book author, and so on, right? So how the database will be stored will be defined in this phase, and the logical structure is now going to be finally implemented in the physical form. Now I'll be looking at the entity relationship model. So ERD is used for conceptual design. We have entities, which are objects or items of interest. Then we have attributes, which are facts about or properties of an entity, and relationships are the link between the entities. So entity has attributes, and different entities may have different relationships. So in a university database, we might have entities for students, modules, and lecturers. A student might have attributes such as their ID, name, and course. Modules might have attributes such as module code and module name. Lecturers could have attributes such as staff ID and name. Students could have relationships with the modules such as enrollment and lecturers or tutors. So entity relationship diagram ER models are often represented as ER diagrams that give a conceptual view of the database and are independent of the choice of DBMS and can identify some problems in a design. So the entities we have just logically declared above consist of students, modules, lectures, and students, lecturer, module, right? And the attributes which exist for a lecturer is ID and the name, as mentioned above. Then student has ID, name, and course. ID, name, and course. So these ovals are representing the attributes for the entities that are declared in this rectangular box. And then we have this last entity over here, module, and it has code and name. So entities represent objects or things of interest, physical things like students, lecturer, employees, products. More abstract things like modules, orders, courses, projects. And entities have a general type or class such as lecturer, module. Instances of that particular type such as my gym are instances of lecturer. And attributes we have just seen above. So there are three important things to remember with entities. So entities are um, the physical things first of all, right? Secondly, and what we are defining here is a generic uh, description, a generic type or class of module, whereas instance of that particular type is, so instances would be, for instance, this module which I'm going to talk about is ITP. So the module has code CE151 and the name for the course is Introduction to Programming. So these specifics or the data sets in this entity are the instances of this um, class or type, right? So this is generic form that which I am defining in ARD, and the specific or the instances would be the data types, data sets.